Okay, so yesterday I assigned this assignment to you. So today I'm gonna go over the whole thing. Since we're working online only, I figure instead of showing you guys an answer key and just leaving it at that and having you ask questions, I'm gonna go over every single problem. On this one, it says find the axis of symmetry. Use a table to find 5 points on the graph. I know I showed you guys the way to do it a little bit quicker, but you do still need to be able to do a table. So on this one, it says state the minimum or max, give the domain and the range. Let's go ahead and do the table first. Remember, you want to find your vertex. That's very important. So finding your axis of symmetry will give you the x coordinate. You're going to use negative b over 2a in order to do that. So over here, a would be 2, b would be 4, c is going to be negative 6. If you put negative b in there, the negative is already part of the formula. B is 4. And then you're going to go 2 times 2. Simplifying that down, it's going to be negative 4 over 4, which is negative 1. Now that we have our x value, we're going to substitute this x value in for the x's in the original. You're going to write y equals 2 times negative 1 squared plus 4 times negative 1 minus 6. And that's going to give you negative 1 squared, which is 1. So two times 1 is 2. 4 times negative 1 is going to be negative 4. 2 minus 4 is negative 2. So negative 2 and negative 6, negative 8. Now we know the y is negative 8. So that means your coordinate for your vertex, the first point you're going to do on your table, x, y, 1, 2, 3, 1, 2, 3, 4, we want more 5. So the first point on your table is going to be negative 1 and negative 8. Remember, we try to put that in the middle of our table. That way we can just go up and down from there. So if you subtract 1, negative 2. If you get this and you subtract 2 from it, you're going to be at negative 3. If you add 1, you're at 0. And if you add 2, you'd be at positive 1. Now you have all the x values that you want to use for substitution. Now this one, I'm going to need extra paper because in order for me to plug in the numbers, I'm going to need extra paper. Alright, got some extra paper here. Put it right there so you guys can see it. So if I start out with the negative 3, I'm going to put that in for the x value. I'm going to go y equals 2 times negative 3 squared plus 4 times negative 3 minus 6. And then that's going to give me negative 3 squared is going to be negative 3 times negative 3, so that's positive 9. 9 times 2 is 18. 4 times negative 3, you're going to have minus 12, and then minus 6. Then 18 minus 12 is 6, and then 6 minus 6, we're down to 0. So that means first one, 0. Then we're going to do it again. And we're going to use negative 2. So we're going to have y equals 2 times negative 2 to the second power plus 4 times negative 2 minus 6. Then you're going to work that out. So you're going to go negative 2 squared, that's 4. 4 times 2, we're at 8. 4 times negative 2, minus 8. And then we have this minus 6. 8 minus 8 would be 0. 0 minus 6 is negative 6. Next point, we're going to use 0 here. This one's going to be nice and easy because 0 cancels out a lot of stuff. Y equals 2 times 0 squared plus 4 times 0 minus 6. Most of you guys can already see where this is headed. 0 squared is 0. 0 times 2 is 0. 4 times 0 is 0. 0 plus 0 minus 6. We're at negative 6. And then, gotta move my keyboard. Last one. Remember, when you substitute this, it should come out to be the same as what we had for the -3, because that's what's happening here. These are the same. So we're still gonna do it for the practice. So 2 times 1 squared plus 4 times 1 minus 6. 1 squared is 1, 1 times 2 is 2. 4 times 1 is 4. Then you go 2 plus 4 would be 6. 6 minus 6, we're at 0. That's what we expected. There's your table. So if you think about this, your vertex, remember, was the one in the middle. So the vertex for this problem, I'll put V in front of this parentheses for my vertex. The x coordinate's -1, the y coordinate's -8. It's also asking if you have a minimum or a maximum. Remember that this graph would be going down and then up. It's positive, smiley face. So that means that this would have a minimum. It would not have a max. And then it says state the domain and the range. So your domain on all of these graphs is going to be all real numbers. And then for your range, remember that if this graph goes down and then up, it's never going to go below that vertex. So that means that your range is going to never cross -8. And if it's always going to be above the -8, then it has to be greater than or equal to. Once again, our A would be the number in the front. If there's nothing there, that'd be a 1. Our B would be the number in front of that X, so it's 2. And our C is going to be the constant that doesn't have a variable, -1. We're still using -b over 2a. So -2 over 2 times 1. That's going to be -2 over 2, which is -1. Now that we have that, we're going to substitute it in again. So it's going to be -1 squared plus 2 times -1 minus 1. So -1 squared is going to be +1. 2 times -1, we're at -2. So 1 minus 2 is -1. And then -1 and -1, we're at -2. So there's our y value. Here's our x value. We can do our table. One, 2, 3, 4, 5. We want to put the vertex in the middle, so that -1, -2 is going to go right here in the middle. Then if we subtract 1, we'd be at -2. If we subtract 2, we're at -3. If we go the other way, if we add 1, we're at 0. If we add 2 to this, we're going to be at 1. We have our 5x values. Now we're going to use that scratch paper again. So when I substitute -3 into there, it's going to be -3 squared plus 2 times -3 minus 1. And then -3 squared means -3 times -3, so we're at +9. 2 times -3, you're subtracting 6. And then 9 minus 6, we're at 3. And then 3 minus 1, we're at 2. So there's our first y coordinate. Then we do the next one. So now we're going to use -2 in there. We're going to substitute the x's with -2. -2 squared is going to be +4. 2 times -2 is the -2 that I have here. And then 4 minus 2 is 2. And then 2 minus 1, we're at 1. And because we already know the pattern that we got last time, if this is your center, if that's 1, this is also 1. If this is 2, this is also 2. And now you have your 5 points. Less work because we know the pattern. When it comes to our vertex, it's this one that's in the middle, -1, -2. If you're looking at this, it's a positive equation, which means that this is going to again be like a smiley face going like a U shape. So that means that it's going to have a minimum. It's going to never go below the vertex. So again, we have a minimum. And our domain, we'll put D for domain. Our domain would still be all real numbers. And then for the range, this is getting kind of crowded, sorry about that. The range, again, it's never going to go below the vertex, so it's never going to go below this y value, which means that your y value is always going to be greater than or equal to the -2. So there's my range, there's my domain. It's a minimum because it never goes below the vertex, and then there's my vertex. X equals -b over 2a. Watch out with those signs. Negative, negative. Remember, if it's subtracting a negative, you're going to be adding 6. 2 times 1, you got 2, and then 6 divided by 2, that's 3. There's my x value. I'm going to substitute that in. So if I put the 3 into there, it'd be 3 squared minus 6 times 3 minus 3. That's going to be 9. That's 3 squared, 3 times 3. This is going to be minus 18. And then 9 minus 18 is -9, and then -9 minus 3 is -12. That means that on our table, one, two, three, four, 5. The one in the middle right here is going to have an x value of 3 and a y value of -12. And then if I subtract 1 and I subtract 2, I get those numbers for the x. And if I come down the other way, I'd add 1 and then add 2. So now that I have my 5 points, I'm going to substitute in. I need some more scratch paper. Here's my scratch paper. Substituting in the 1, I'm going to go y equals 1 squared minus 6 times 1 minus 3. 1 squared is 1. 6 times 1 is going to be 6, so it's going to be -6 times 1 is -6. And then 1 minus 6 would be -5, and then -5 minus 3 is -8. And there's my y value. Okay, so there's my first one. Then I do the same process with the 2. Two squared is 4. -6 and 2 is -12 here. Oof, that's squeezed in tight. Sorry about that. 4 minus 12 is -8. -8 minus 3 is -11. And then there's my second y coordinate. I don't have to do the other 2 because I already know if this is -11, this is -11, and if this is -8, right here is -8. This is still positive, so when I find my vertex 3, -12, my vertex, I should have spaced that out more. That's a V. So my vertex 3, -12. This is a smiley face looking graph. So that means that it's gonna have a minimum and then it's gonna go back up. The vertex would be that minimum. And then for the domain, we'll put D for domain, it's still all real numbers. And then for my range, remember that that's talking about the y values up and down. So that means that this range will never go below that -12. So it has to be greater than or equal to -12. I'm going to put a little line right here because it's getting crowded. x equals negative b over 2 times a. Negative negative 6, we're at positive 6. 2 times 3, we're at 6. 6 divided by 6, we're at 1. There's an x value, substitute it in. One squared is 1. 1 times 3 is 3. Negative 6 times 1, we're at minus 6. 3 minus 6, this is negative 3, and then negative 3 minus 5, it's negative 8. That means that our vertex is 1, negative 8. If we do our table, that's going to be our middle coordinate. So 1, 2, 3, 4, 5. That means the third one right here, x is 1, y is negative 8. We subtract 1, 0, subtract another one, negative 1. If we add 1, 2, add another one, we're at 3. We have all of our x values. Get some more scratch paper out. Scoot this over so you can see the work. So y equals 3 times negative 1 squared minus 6 times negative 1 minus 5. Negative 1 squared is 1. 1 times 3 is 3. Negative 6 and negative 1 is going to make it positive 6. And then 3 plus 6 is 9. And then 9 minus 5 is 4. Next part. I'm going to use 0. I like 0. 0 cancels out a bunch of stuff. It's really nice. Zero to the second power is 0 times 0, so that's 0. 0 times 3, still 0. Negative 6 times 0, still 0. So 0 minus 0 is 0, and 0 minus 5, you're at negative 5. We have the 2 that we had to work for. These other 2 are going to be easy. If this is negative 5, where the 2 is at is going to be negative 5. And if the negative 1 gave us a 4, that means the 3 will also give us a 4. So this is still positive. That means that your vertex is going to be your minimum. Our vertex was 1 and negative 8. It is a minimum. For the domain, it's still all real numbers. Kind of crowded, but it fit. And for the range, I should put a colon instead of an equal sign. For the range, it's gonna never go below the negative 8, so it has to be greater than or equal to the negative 8. Okay, next part. These graphs are already done for you. So you're finding the vertex, the equation of the axis of symmetry, and the y-intercept for each graph. So the vertex is going to be the coordinate that's right here where that graph changes directions. So the origin is 0, 0. I'm going 1 to the left. That's negative 1. And then I go 1, 2, 3, 4, 5 up. That's a positive 5 for the y. For the axis of symmetry, I'm going to abbreviate axis of sim. So my axis of symmetry would be a vertical line that goes right through that vertex. And that's going to be x is negative 1, which is from this coordinate. That would be the equation of the line, because it's a vertical line. And then we have our y-intercept for each graph, and you're going to have to look for where it crosses the y. That's what it means. So the y-intercept, it looks like it's right here. And that y-intercept, the x is 0, and then it's 1, 2, 3 up. So y-intercept is going to be 0, 3. That's interpreting the graphs when they're already given to you. The next one, same basic process. Our vertex is right here where it's changing directions. It would also be considered the minimum. This coordinate goes 1, 2 to the left, 1, 2, 3 down. So 2 to the left and 3 down. Our axis of symmetry would be a vertical line that goes through that vertex. So that vertical line is 2 to the left. It'd be x equals -2. That'd be the equation of the line. And then for the y-intercept, that coordinate where this is crossing the y-axis looks like it's right here. So that point, x isn't left or right, so the x is 0, and the y value goes up 1, +1. Next graph to interpret. You know what I mean. The next graph to interpret, the vertex is right here, where it changes directions. This would be a minimum, by the way. The x-coordinate is -1. The y-coordinate, 1, 2, 3, 4, 5, 6 down, would be -6. The axis of symmetry would be x equals -1, because that is the coordinate, the x-coordinate for the vertex. And then your y-intercept would be, it looks like it's actually crossing here. So x is 0, y is -2. Last one. The vertex is right there where it changes directions. This example would be a maximum because it doesn't go above that vertex, it just falls back down afterwards. But your vertex coordinate, x is 0, y is 1, 2, 3, 4, 5. Your axis of symmetry, you would have the x value, which is still 0 because it's right there. And then your y-intercept would be the coordinate where it crosses the y-axis, which on this example is actually the vertex again.